The Hubble Space Telescope never fails to amaze us as it keeps presenting spectacular images from the corners of the universe that have been untouched yet. Recently, NASA scientists have a new thing to ponder upon as the orbiting observatory has presented a new mysterious image of a superbubble between a nebula. As NASA describes the complex nebula, it is filled with glowing gases, lanes of dust, and stars of all ages. But there's a catch. It has a perplexing gap in the middle. So what is this new nebula discovery? Let's take a look in today's video. Before we begin, make sure you like and subscribe to the channel. Turn on the bell for the latest notifications and updates. With that said, let's dive right into today's content. Located 170,000 light-years away from Earth, NASA says that the presence of the nebula named N44 is still something of a mystery. Although it is filled with glowing hydrogen gas, dark lanes of dust, massive stars, and many populations of stars of different ages, the most distinctive feature of N44 is the gap called a superbubble that has been captured by the Hubble telescope. The gap should not be mistaken for a regular one, as it spans a massive 150 light-years. In its explanation, NASA said that it might have resulted from the expulsion of gas from the nebula's interior due to stellar winds. Presenting another possibility, it stated that explosions might have sculpted the hole. Stellar winds expelled by massive stars in the bubble's interior may have driven away the gas, but this is inconsistent with measured wind velocities in the bubble. Another possibility, since the nebula is filled with massive stars that would expire in titanic explosions, is that the expanding shells of old supernovae sculpted the cosmic cavern, as per the administration. N44 is classified by NASA as an emission nebula with superbubble structure located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way in the constellation Dorado. It was originally cataloged in Carl Heines's Catalog of H-alpha emission stars and nebulae in the Magellanic Clouds of 1956. Now, for those who do not know, an emission nebula is a nebula formed of ionized gases that emit light of various wavelengths. The most common source of ionization is high-energy ultraviolet photons emitted from a nearby hot star. Among the several different types of emission nebulae are H2 regions, in which star formation is taking place, and young massive stars are the source of the ionizing photons, and planetary nebulae, in which a dying star has thrown off its outer layers, with the exposed hot core then ionizing them. Usually, a young star will ionize part of the same cloud from which it was born, although only massive hot stars can release sufficient energy to ionize a significant part of a cloud. In many emission nebulae, an entire cluster of young stars is contributing energy. Stars that are cooler than around 25,000 Kelvin don't give off enough ultraviolet radiation with wavelengths shorter than 91.2 nanometers, the wavelength needed in order to ionize hydrogen atoms. This results in the reflection nebulae around these stars to give off more light than the emission nebulae. Stars that are higher than 25,000 Kelvin generally give off enough ultraviolet radiation to cause the emission nebulae around them to be brighter than the reflection nebulae. The nebula's color depends on its chemical composition and degree of ionization. Due to the prevalence of hydrogen in interstellar gas and its relatively low energy of ionization, many emission nebulae appear red due to strong emissions of the Balmer series. If more energy is available, other elements will be ionized, and green and blue nebulae become possible. By examining the spectra of nebulae, astronomers infer their chemical content. Most emission nebulae are about 90% hydrogen, with the remaining helium, oxygen, nitrogen, and other elements. Some of the most prominent emission nebulae visible from the northern celestial hemisphere are the North American nebulae and the Veil Nebula NGC 6960-6992 in Cygnus, while in the south celestial hemisphere, the Lagoon Nebula M8 NGC 6523 in Sagittarius and the Orion Nebula M42. Further in the southern hemisphere is the bright Carina Nebula NGC 3372. Emission nebulae often have dark areas in them which result from clouds of dust which block the light. Many nebulae are made up of both reflection and emission components, such as the Trifid Nebula. Since the N44 nebula, which spans 1,000 light-years, houses stars of all ages, astronomers have found one supernova remnant in the vicinity of the superbubble and identified an approximately 5 million-year age difference in stars between, within, and at the rim of the superbubble, indicating multiple chain reaction star-forming events. The N44 is also an emission nebula, which explains its majestic glow. The bright light emerging from the cosmic entity is accredited to the cooling of its ionized gas from its higher energy state to a lower energy state, making it emit energy in the form of light. If you look closely, the deep blue area in the right-hand corner of the image is the brightest and one of the hottest regions of the nebula. Well, that's all for this video. Hope you enjoyed watching this one. Thanks for watching.